G'day viewers. If you haven't already done so, please watch our previous episode, that is episode 55. In fact, it would be prudent to watch our Bob Lazar playlist in full. In this video presentation, we're going to reconcile the impossibility of faster than light travel with space alien technology based upon element 115. However, I stress that the contents of this episode are conjecture, our statements may be incorrect, so viewer discretion is advised. Having said this, let's move forward. To begin with, we know that according to standard physics, and as demonstrated by space-time diagrams, faster-than-light travel, including instantaneous wormhole travel, is impossible. However, if Bob Lazar is correct and the space aliens come from another solar system, how could they have done it? And how can we reconcile human understanding of physics with space alien technology? Well, standard physics has given us some clues. We just need to modify our interpretation a little. What do I mean? A concept which has enjoyed increasing popularity in mainstream science, and of course Hollywood, is the multiverse. The idea of an infinite number of universes existing aside from our own seems to have become accepted popular fact, despite the lack of scientific evidence. There is no physical evidence of a multiverse, none whatsoever. Okay, I've depressed you enough. Let's have a look at what Newton might have thought about the idea of the multiverse.
Let's now consider the Newtonian solution for escape velocity. We'll begin by borrowing a slide from episode 22. Next, imagine that the entire mass of the universe was compressed into a single spherical object, analogous to the Earth per se. In such a case, under Newtonian law, the universe has an escape velocity, just like the Earth has an escape velocity. The Earth's escape velocity is about 11.2 kilometers per second, and the Milky Way escape velocity is about 781.3 kilometers per second, assuming a total galactic mass is shown. But what would the escape velocity be for the whole universe? Well, that's actually very easy to calculate. Utilising this standard and well-known equation, but substituting cosmological mass and Hubble length as shown, we obtain the value of cosmological escape velocity. This is the required velocity for an object to escape the gravitational pull of the universe, if its entire mass were compressed into a single body. In this example, the escape velocity is the speed of light. Okay, when a spacecraft escapes the Earth's influence, it disappears into the solar system. When an object escapes our galaxy, it disappears into the intergalactic void. But what might happen if a spacecraft escaped the universe? Where might it go? It can't just cease to exist. That would violate the law of conservation of energy. It's required to go somewhere, and the obvious choice is the multiverse. The Newtonian escape velocity, as we have calculated, is standard physics. There's no mystery here. However, we have just taken our first multiverse step. Let's take another one. In our previous episode, that is episode 55, we learned that wormholes were entirely acceptable within general relativity, at least according to Einstein, Rosen and Thorne. However, according to Kip Thorne, they require exotic matter in order to function as we might like. The problem is that we can only obtain exotic matter from the Easter Bunny's basket. It doesn't actually exist in the real world, but despite this, Kip Thorne still put his name to it. Anyway, leaving that aside, what Thorne shows me is that general relativity solutions don't really work very well for interstellar travel applications within our universe. However, considering that general relativity supplanted Newtonian mechanics, and Newtonian mechanics suggests a multiverse as discussed on the previous slide, it follows that Kip Thorne's wormholes might be conduits to the multiverse. Given that exotic matter doesn't exist and is nothing more than a convenient wave of the hand, I can't see another option for wormholes other than connectivity to the multiverse. Thus far, we've established that Newtonian mechanics was supplanted by general relativity, and general relativity is an anchor because it requires impossible ingredients for interstellar travel within our universe. So, if we are being visited by space aliens as Bob Lazar claims, then how are they doing it? Well, if you've been watching our videos, you'll know that the answer to this question is element 115. So, let's dig a little deeper into the manner in which element 115 may be working. In our previous episode, that is episode 55, we postulated that element 115 acts as a quantum vacuum inhibitor serving two functions. One of them is that it destructively interferes with the random emergence of conjugate pairs of virtual photons, that is gravitons, from the zero-point field. In other words, it suppresses the Casimir effect. Consequently, the distance between points A and B collapses to no more than 12 femtometers, which was the condition at the instant of the Big Bang and the condition of maximum permissible energy density. Please watch the previous episode if you have not already done so. However, the obvious question is, why should space-time collapse between A and B? Well, let's have a think about it. We know for a fact that space-time does not naturally exist without the quantum vacuum, and the ground state of the quantum vacuum is the zero-point field. So, every cubic millimetre of space-time throughout the observable universe contains the quantum vacuum, and most of it is in the form of the zero-point field. Moreover, from previous episodes, we identified that a layer of unobservable reality exists beneath the zero-point field. If it didn't exist, then feeding energy to the Casimir effect from the quantum vacuum would violate the law of conservation of energy. We termed this layer of unobservable reality the dark reservoir of quantum potential energy. What is particularly important to note is the term potential energy. This tells us a lot whether we realise it or not. What do I mean? Let's use an analogy. We can consider the dark reservoir of quantum potential energy to act like a battery, powering the Casimir effect via the zero-point field interface. We all know from daily life that a 3-volt battery can be manufactured to any size. It can be the size of a button, or it can be much larger. Size makes no difference to potential energy. Similarly, physical dimensions make no difference to potential energy. Thus, if the Casimir effect between 2 points in space-time can be suppressed, that is, switched off in a manner of speaking, then the three-dimensional space-time between these 2 points cannot be said to exist. How so? Well, if the nature of the cosmos is a 4-dimensional hypersphere, then if we suppress the 4th dimension by suppressing the Casimir effect, we must also be suppressing the other 3 dimensions too, because they exist at right angles to the 4th dimension. If the 4th dimension is missing per se, because its interface to 3-dimensional existence has been suppressed by element 115, then 3-dimensional space-time must also be absent. If this were not the case, then we'd be claiming that we can separate one dimension from the rest. This, of course, is ridiculous. If we remove the columns holding up a roof, the entire structure collapses. The same is true of 4D space-time. By collapsing one dimension, the other 3 dimensions must also collapse. Let's now summarise what we've learned. In this episode, we have reconciled the impossibility of faster-than-light travel with space alien technology based upon a stable version of element 115. We have shown that general relativity as an engineering tool is inadequate with respect to interstellar travel because it requires exotic matter, as well as not considering the quantum vacuum in any way. We have shown that standard physics tends to lean into multiverse solutions. This outcome in itself is cause for alarm. As ridiculous as the application of element 115 may sound to some people, it is far less ridiculous than the exotic matter required by general relativity. Element 115 has actually been made on Earth, exotic matter has not. However, because general relativity is so ingrained in standard physics, anything stated by general relativity seems to be taken as gospel, irrespective of how bizarre it may appear. Therefore, if general relativity is affected by the lack of consideration of the quantum vacuum, it stands to reason that special relativity should also be affected in some way. But that's a discussion for another day. Maybe faster-than-light travel is possible once special relativity considers the quantum vacuum. Who can say? In this episode, we have shown that interstellar travel may be possible by technologically targeting the interface between the dark reservoir of quantum potential energy and the 3 spatial dimensions we are all familiar with. By technologically targeting the interface, that is, the zero-point field, we may be able to suppress the Casimir effect and, consequently, collapse the space-time between 2 distant points. Please note that we have not proposed any form of wormhole. We have proposed a collapse of space-time, not a severe bending of it, as is the case for a general relativity solution. This is an extremely important distinction. Severely bending space-time requires exotic matter, according to general relativity. Collapsing space-time does not require exotic matter, according to our element 115 theory. Thus, we propose that element 115 acts as a quantum vacuum inhibitor suppressing the Casimir effect. Hence, simplistically speaking, no Casimir effect equals no space-time curvature. This literally means that the distance between 2 points collapses to a separation of no more than 12 femtometers if the Casimir effect between them has been cancelled. So, in summary, we have established a possible explanation for the manner in which element 115 may permit interstellar travel based upon quantum mechanics, specifically quantum probabilities. However, once again, we stress that the contents of this episode are purely conjecture. The conclusions presented may be incorrect, so viewer discretion is advised.